Hello, everybody. Welcome back from the break. I hope everybody is well caffeinated. I hope everybody got a coffee. Great. Okay, so this topic today and this talk is about observability, and for this talk we have a local here from Vienna. I was told that he is still allowed to live with his 2 cats, so lucky guy still. His slogan is he's fighting computers since '99, successfully it appears. And today he's going to introduce us to why agents actually matter in observability tools. He's a developer experience engineer at Grafana Labs here in Vienna, here in Austria. So this is his local stage. Give me a hand for Dominik Süß.
So, and we have the first technical difficulties, but we'll figure that out in a second. Yeah, here we are. All right, so I'm here to talk about observability. I tried to stick with a spy agent theme, but then I realized that I don't actually know that many spy movies, so you'll have to excuse the title. I work as a developer experience engineer for Grafana Labs. First of all, who here knows about Grafana or has used Grafana before? Okay, that's great to see, because now I don't have to explain the entire thing. In short, we do observability. We do that by visualizing your data, but also storing your data. And for storing your data, that's a difficult topic, since not all applications are well instrumented. Sometimes it's hard to get the data from point A to B. And as a developer experience engineer, my goal is to make it as simple as possible for new users to get their data into the backend. And one pain point we often see is the understanding of an agent. Why do I need to deploy an agent? What does this agent actually do? So that's why I'm here talking about observability agents. First of all, why should I even care? I really only want to have my application send data and have it arrive at the backend. Why would I even need an agent? So the simplest way for the data to go is just straight from your application to the database. No middleman. You have a simple architecture. You don't need additional components. Your developers have all the power. If they need to change any metrics, if they need to change any labels, they can do it from the environment where they're most comfortable, and that is their own application. But there are some negatives, and the last time I held this presentation, the negative list was so long that people got bored of this slide, so I provide you with a bit of entertainment for this one. The biggest negative is that every change requires a redeployment. Now, we're all cloud native here, and we all know deployments are snip of a finger and the deployment is done, so obviously that isn't an issue. But there are still some other negatives, like if your application crashes, this might lead to data loss, as the application has not fully finished sending the data. It might lock you to the backend if you're sending data using a proprietary protocol. If you change your observability solution, you have to re-instrument your whole application, which can be a bit tiresome if you do it multiple times. The data is also hard to enrich. Let's say you're running your application in Kubernetes and want to know which node this came from. Then your application needs to know which node is it running on. You can pass it down for environment variables, but that introduces additional failure points and configuration effort. You can have your application talk to the Kubernetes API directly, but you get the point. It's hard to enrich. Also, it's a bit difficult to do cost control here, as your application really only knows about itself and can't really factor in how many instances of this are running. Do I really need to send this amount of data? Do I need to throttle myself? So this approach isn't ideal. Now, most of you probably also know about Prometheus, and Prometheus has a pull-based approach instead of a push-based one, which has some extra positives, like, for example, the fact that you can reuse. If you're already using Prometheus as your storage backend, then you can also reuse it to scrape your information. It offers basic enrichment, because if you pull from somewhere, you need to find that location somewhere in the first place and can add to that information based off of that. And yeah, you can do it straight from the backend, which is nice. But this approach really only works for metrics, so there's no real method to pull traces. There is a way to pull logs. I'll get back to that later on. But not all storage backends support that, so you're basically locked to a single vendor again. But what if we put something in the middle here? If we put a secret agent in here, which talks to your application, which can either pull or receive pushes, and then sends it off to the telemetry database. Now, we don't have to imagine that. There are many agents available. There's just a few mentioned up here. Those are all open source. For the rest of the talk, I will be talking about the OpenTelemetry collector. If not otherwise specified, there will be one specific slide where this is relevant. But other than that, everything I mentioned you can do with the OpenTelemetry collector. Now, this is mostly where the pitch ends. Most vendors just tell you, yeah, just deploy the agent and we'll take care of the rest. And something will happen in there, you don't need to worry about that. Just deploy it and it's done. So this kind of introduction should have communicated the explanation to why we need agents, why it's preferable to have an agent, but not actually what they do and how you should manage or deploy them. And for that, we have to get some terminology out of the way. That slide was a bit too early. Who here knows of OpenTelemetry? Just raise your hand. Okay, that's also a very educated audience. Who here can tell me the difference between OpenTelemetry and OTLP? That's fewer hands, so we need to get some terms straight. OpenTelemetry, that's the set of standards for telemetry data. Now, when I'm talking about telemetry, I mean logs, traces, metrics, profiles. Those are all telemetry data. I just don't want to repeat logs, metrics, traces, profile all the time. So OpenTelemetry, that's a standard for telemetry data. OTLP, that's the OpenTelemetry line protocol. That's the specific transport protocol used by OpenTelemetry components. And then there's also the OpenTelemetry SDK, which is the language-specific implementation on how you can instrument your application. So this, you can see why this can get confusing. I'll try to stick to the terms, and if it becomes unclear at some point, just yell at me what exactly I'm talking about. So OpenTelemetry, set of standards. OTLP, that's the transport protocol. The SDKs, that's the stuff you put in your application. Now, an agent or collector basically does three things. It ingests your data, it processes the data, and then it exports that data again. For ingestion, as I said, you can either push to the collector directly or have it scrape your application endpoint. But you're not limited to those two data ingestion methods. You can also have the collector do eBPF processing itself, where it can get metrics from the host machine through the kernel. You can also have application-specific extractors. So if you know from I say old days, from the Prometheus exporter days, where you had a separate exporter for your database, the node exporter for your nodes, where you had application-specific exporters. In most cases, the collector can do that as well, so you don't need to deploy an additional component. And the cool thing about the collector specifically is it supports many, many different ingestion formats. So basically, if your application is emitting telemetry in some shape or form, there will be an ingester to ingest that data. Now, once the data is ingested, then the collector can transform it in any way you seem fit. This processing can be just a simple relabeling of adding labels, removing labels, renaming stuff. It can also generate new data. So specifically when we're talking about traces, you can do conversions like traces to metrics, where you have X amount of spans coming in, and then you can generate a metric based off of that and throw the spans away, so you only have the metric in the end. You can also do logs to metrics. Those are all conversions which can happen in the processing step of the collector. You can sample your data. Again, this is very much related to tracing. Sampling is the process of having all your traces at one point and deciding, I want to keep that one around, I don't need to keep that one around. And by doing it at the collector, you can make a more informed decision, but I'll get back to that. And the last point, which is really relevant for larger installations of the collector, is routing and multi-tenancy. So in the collector layer, you can start to split your metrics and telemetry based off of labels and say, okay, this data came from team A, so we're sending it to storage backend A, but this data came from a completely different team, so we're sending it off to a different storage backend. Now, for the actual sending off, again, the collector supports many different protocols, so you can mix and match, which provides you the advantage of not having to re-instrument your application every time you switch your storage backend. So you can ingest in the OTLP format and then send it off to a Prometheus instance. You could ingest using Prometheus scraping, export it to any OpenTelemetry compatible storage backend. That's really the beauty. You can mix and match whatever you want. Now, how are they configured? As with everything DevOps, it's YAML. So you're stuck with that. There are some other solutions. If you're interested, you can talk about that with me later on. And the configuration mostly resembles the same three stages I outlined before. You have receivers, where you specify how can I ingest the data. You have processors, which run through the different available methods. And then you export it to another endpoint. In the end, you have pipelines which say, for traces, receive on this endpoint, process it using the following steps, and then export it using another exporter. You can have as many receivers, as many exporters, as many processes as you want, just need to define them correctly. So that's the collector part of the way. We now know what a collector does. We now know how we configure it. But how do we get our application to actually send those metrics? And this is pretty relevant because the decisions you make at this point affect how you will deploy the collector later on and how well you can scale with that. When you instrument a new application, you have a few questions you have to ask yourself. I split it up into the core telemetry types. So for metrics, do you want to push your metrics or do you want to pull them? So yeah, pretty straightforward decision. You have to also decide if you want to have delta metrics or cumulative metrics. The difference being delta metrics only send what has changed since the last time you sent data, and cumulative metrics sending the entire data set at every interval. And then I wrote down Prometheus versus OTel here. Then you have to choose how you want to lay out your data. This is mostly relevant if you're using Prometheus or OpenTelemetry, since Prometheus has the convention of adding unit suffixes to the metric names themselves, using underscores, where OpenTelemetry uses dots and doesn't have the Unix suffix. What I want to say with that, choose one style and be consistent. For logs, you have the most fundamental decision is, do you want to log to a file or do you want to log to the network? And the contents of the logs should ideally be structured. I don't think there's a big discussion about that. But do you want to log them using JSON or something more humanly readable like logFMT? Traces are, in my opinion, the simplest format. There's not that much you can do wrong. You have to choose a protocol, which I didn't mention up here, but you have to choose it at some point. And then you have to decide if you want to do tail sampling or head sampling. Tail sampling is the process of having the entire trace available. If you're working in a distributed system, for tail sampling, you have all the different subspans from all different microservices available at one point, and then you make the decision. Whereas head sampling happens in the application that first receives the request. Based off some percentage or specific headers, it would either record the whole trace or just don't record it at all. And for all those metrics, for all those telemetry types, at the end you have to decide, do I want to enrich at the application or at the collector level? Since this is a Kubernetes conference, I've made some decisions for you so that you don't have to. For metrics, I prefer the pull approach for the simple reason that it's more scalable. I'll talk about scaling patterns later on, but keep in mind pull is, in my opinion, more scalable. Also, these are just my opinions. I think those are good opinions, but if you want to fight me on them, just find me outside. I prefer cumulative metrics. It's easier to debug. You can have a wider range of out-of-time writes. Because if you're sending delta metrics, you always have to find the previous reference point, and if that's too far back, it can be expensive to fetch it and then recompute the entire series based off new data you received out of order. And I just prefer the Prometheus format. That's it. There's no big opinion on that one. For logs, this opinion I hold strong. Write your logs to files. Now these files can also be standard out or standard error. And the simple reason for that is crash resilience. The worst thing that can happen is your application crashing, and you want to take a look at the logs, but the logs were not sent because your application crashed. So now you don't know where to even start debugging. Log to a file, have the collector watch that file, and send it off to your storage backend. That's the most resilient approach. Now, I also prefer logFMT to JSON for the simple reason, if you're debugging in Kubernetes, you're messing around with pods, deployments, and you're already in that command line flow. And if you want to take a quick look at a pod without opening your browser, going to your observability solution, finding those logs, you just do kubectl logs. And if it's JSON, there's nothing worse than reading a bunch of JSON and figuring out which section is part of which log message. Using logFMT, it's way easier to debug as a human. Now for traces, I don't think there are any contrarian opinion on that one, but tail sampling offers you much more flexibility because you can have a complex rule set of, okay, this was an error request, so we should probably keep that around, but this was just fetching a static image and was successful, so we can drop it. Collector enrichment, this is the talk about collectors. It just enables you to decouple those decisions from your application at a higher level. So now you should have a basic idea of how your application should be ideally instrumented, but how do we then deploy this collector to take that data and ship it off somewhere else? The most basic deployment strategy is just deploy the collector as a deployment, have your application send it to the specific service, have the collector send it to a storage backend. It's easy, not much to it. It has some scaling issues, which I'll get into in other slides, but for most use cases, this will probably be fine for you. Now, you can also deploy the collector as a sidecar to your container. This is especially easy in Kubernetes, as you know. And the advantage of that is if you have an application exposing sensible metrics or logging to a random file on disk, you can have a collector which is just for this specific application and then send it off to a next layer of collectors, which will then do the general purpose processing, but the application-specific stuff is kept in the sidecar. And another approach, especially useful for logs, is have one collector per node, and each app sends their data to the specific collector on that node, which then gets aggregated again at a later level. Now for logs, as I said, the sidecar is a good choice if you have files written out to not standard out or standard error. You can have a collector sidecar scraping that specific log file. But for general purpose applications and newer applications, you should try to use the node-based approach, where you have one collector per node, and it will talk to the Kubernetes API to figure out which pods are running on that node, and then scrape the standard out and standard error streams of these specific pods, label them appropriately, and send them off to the storage backend. This is great. You don't have to do any instrumentation on your application. Just write to standard out, standard error, and you're done with it. Now, you can't always do that. And the reason for that being either security constraints. So if you're running OpenShift specifically and not using the official cluster logging operator, you will have troubles configuring your daemon set to use the correct permissions to actually be able to scrape those logs. The other part could be you don't own your Kubernetes cluster. You're buying this as a hosted service, and you don't have permissions to run daemon sets. In those cases, you can have the collector talk to the Kubernetes API directly. Since you can use kubectl logs on the command line, why shouldn't the collector be able to do it? Downside of this approach is, of course, this puts a lot of stress on the Kubernetes API, but sometimes you have no other choice. And this is possible if your lowest privilege level is creating a service account. Now, those are the basic deployment patterns. The ones before, mostly for metrics and traces, and this one for logs. But what if you have too much data? What if you exceed those requirements? Well, we're in Kubernetes land. We just scale up our deployment, have a service in front of it, that's it. Your application will choose a random collector out of the list, and yeah, it will just do that. This has a few issues for tracing specifically. If you have traces going to different collectors from different applications, you don't have the full picture and can't do sampling that well. But the bigger issue is if one application starts to just hammer your collector with data. So this application is sending way too many traces, way too many metrics, profiling information, whatever you have. That will still not properly distribute the load, and one collector will be overwhelmed. What's the way around that? Use a gRPC-based load balancer. So the OTLP protocol works over gRPC, and if you have a gRPC-aware load balancer, requests are split on the request level. And if one application decides to send a lot of data, this gets split on a request basis and evenly distributed to the scale-up collectors. For metrics, if you have pool-based metrics, this approach kind of works as well. You have multiple collectors scraping the same endpoints, but you might already be able to see the issue with that. Now you have multiple collectors scraping all the endpoints, and you have the same data at multiple collectors, so you need another layer to deduplicate that, and it's a lot of data which you don't really want to replicate that often. So it's not ideal, but it works. If you're doing the same thing for logs, that's fine again. In the end, that's the same approach of having a collector per node. So each collector is only responsible for a subset of applications. So in theory, this works for logs. Why shouldn't it also work for traces? And that's what the OpenTelemetry team thought as well. So they developed a new service called the target allocator. The target allocator will get a list of services to monitor with pool-based metrics and then configure the collectors appropriately. So the target allocator is a separate service you need to deploy. It will fetch all instances of your application and then say to the first collector, you monitor this subset, you monitor this subset, you monitor this subset. And based off of that, you can have a more evenly distributed scrape pooling. So this is the one specific slide where it's not possible with the collector. This is using Grafana Alloy as the collector level. And Alloy has the capability to cluster with other Alloy instances and can then evenly distribute the load without the need for an additional component in the cluster. So those are the different scaling patterns for the collector, but this might just be too much for you. As I said, use the simplest approach you have available and scale out from there. It's really easy to switch between different scaling patterns because, again, the collector can take any data and spit out any other data format, so you're fine to go with that. But I have some more recommendations to give you on your way. When you're instrumenting your application or when you're adding instrumentation to an old legacy application, and especially deploying collectors, you should separate telemetry types. The reason for that being logs scale differently to metrics. Your application won't send the same amount of metrics as it does logs, as it does traces. And if you split up at the earliest point, you can scale those components independently. You can collect logs on a node-based level. You can cluster the metric scraping, as I've shown before, and then you can use a load balancer for traces. This allows you to use the appropriate scaling infrastructure for specific tasks. You can also chain collectors. So I didn't mention it explicitly, but it's the same protocols all the way down. So you can have one collector only collecting information from team A, one collector only collecting from team B, aggregate a layer above, so maybe on the cluster level. And if you as a company have multiple clusters, then you can aggregate that once again. So you can build complex hierarchies using collectors, especially useful for multi-tenancy and team separation. Now, just because you can doesn't mean you should. So try to keep consistency with your protocols. Don't start out every project with a new instrumentation library. Conversions are usually possible and very clean, but if you chain too many conversions, it's easy to lose sight, it's easy to lose metrics, it's easy to lose labels. Avoid it by trying to standardize on one protocol set and then keep using that from that point onwards. Also, this is with regards to label conventions, so don't have an application have their data label be instance, then one host name, then one job, then one machine. Try to standardize because that allows you to have better queries, more consistency, and also if you have team members switching from teams to teams, then they will be up to speed as well. And the last point, instrument early. If you have the possibility to start a fresh new project, start with observability in mind, start instrumenting as soon as possible, because tagging it later on can be cumbersome. There are automatic instrumentation layers. There's also the OpenTelemetry collector operator, which can automatically inject observability libraries into your project. I didn't think we'd have time to discuss that, but we can discuss it later on as well. But start with it in mind, your manual instrumentation will always be better than the automatically generated one. And if you only have time to implement one signal, if you're really bound for pressure, but you don't know what the application is doing, try to implement traces first. Traces allow you to go from traces to metrics, from traces to logs, and from that point on, you have your most important metrics. So traces are key. Some other general recommendations I can give you if you're starting out using the collector are, don't be confused by the repository split. There is the OpenTelemetry collector core and the contrib version. The core version only has a few select receivers and exporters, and also processors, with the contrib version being much larger, having more choices available to you. And this separation offers the benefit of choosing which kind of components you want in your distribution, because every additional component you add might increase the attack surface, but also just the binary size and size of the collector running. But yeah, if you have any questions about that, approach me later on. that's it from my side. I think we have time for a few questions. And other than that, if you don't get your question in now, just approach me outside later on, and I'm happy to talk anything observability. Thank you.
Great. Perfectly on time, really like minute-wise, amazing. I love that, also makes my job way easier. If you're into the stickers on his notebook, I was told that there are some stickers available, just approach him, not a good reason. Do we have any questions? Spoiler, we have gummy bears for each question. Yes?
Could you please elaborate why?
The mic, please. Sorry.
Could you please elaborate why one should start with traces?
Just the reasons I mentioned before, that if you are able to, if you have traces efficiently set up, then you can infer a lot of information from that, because each trace in the end is a sequence of events, and what's the difference between logs at this point, because logs are also just events that happen in a sequence of time, so you can convert from traces to logs easily. And the same thing goes for metrics, as I mentioned in one of the earlier slides. If you have a trace for each request, and you can aggregate that over a time frame, you can convert it to a metric, and then you have a metric for your request rates as well. So the main reason is just flexibility and the ability to go from traces to any other telemetry signal you want to. Profiles I don't think are possible, but every other signal should work.
One more question, please. Is Grafana agent completely replaceable with Alloy? Because now I'm using Grafana agent quite severe, and the Alloy is complete replaceable.
Yeah, I got that question last time I held this talk as well. So the short version is Grafana agent had two modes. For all of those who don't know the Grafana agent, it was the Grafana distribution or the Grafana version of an agent. It had two modes. It had the static mode and the flow mode, and Alloy is a successor to the flow mode. So if you were using flow mode before, you can just replace it with Alloy. We have conversion tools available as well, and the same thing for the agent. But long-term, the agent is being replaced by Alloy.
Yes, another question over here.
With the different scaling patterns for metrics and logs, do you usually do those in different collectors, or would you recommend doing those in different collectors, or keep it, like for example, only as a daemon set and take that as a start point for metrics as well?
So this really depends on your specific cluster setup. I would recommend doing the pattern of having one collector per node responsible for logs, just because it's easier to do it that way than to have every team reinvent the wheel by having their own collector scrape only their own logs. But in general, I would keep logs separate. But if you don't have the permissions to run daemon sets, then you'd have to do it in the. You can of course do it in the same collector as every other signal as well. It's also important to mention that the collector, of course, has metrics on its own, so you can see how well different parts of the collector are utilized and base your scaling decisions based upon that.
Maybe as an extension of that question, if you have multiple collectors, how does the stitching together of metrics and traces work then?
So that's a good question. For traces, it's pretty easy, since distributed tracing works by having separate spans from wherever you produce them, and then the stitching together only really happens in the storage backend, or in intermediate collectors where they wait for a certain amount of time to have the complete trace information. For metrics, this can be difficult, so I had one slide with the deep duplication approach here. This is not officially supported, so this is not a single component you can use, but this is more of a homegrown approach you can build by having filtering rules where you say each of those collector instances on the first level, each of those adds a label, this came from collector A, this came from collector B, this from C, and then you can have a rule to only take a single version of that label and deduplicate on that level. So that's the way you would stitch together metrics. There are some storage backends which do that for you. I think Mimir does it that way. So if you have multiple instances of the same metric, you can tell the storage backend, this label is where the redundancy comes in, and then it's stitched back together. But for the other patterns where you do target allocator, for example, at this level, you don't really need to do any stitching together because all metrics are different from each other. all are separate series, which are then really only combined at the storage layer.
All right. Thanks for the great answers. Thanks for the great talk. I see there's still a lot of interest, so please just catch Dominik outside. He won't be able to run far, I guess. He will stick around. That's what I want to say. Thanks for contributing.
Thank you so much.
Just a small gift. Yeah, find him outside. We'll be back in 10 minutes with the last talk before lunch. Great applause, please.